Hi, everyone. I'm going to describe our view from NUMO about how we see urban air mobility from the point of view of urban transport. In NUMO, we work around tech-enabled disruptions in the mobility sector, and we try to engage with government, private sector, civil society, and others to understand how these new initiatives, how these new services have started to come up, how we can use them, and how we can generate the best solution for everyone. So I'm going to talk a little bit about urban mobility as it stands now, and then come into the topic of urban air mobility more specifically. So first of all, we normally have known always that every mode of transport can have its own place. It doesn't mean that cycling, walking, public transport must be used for every trip. It also doesn't mean that cars or taxis or any other mode has to be used at another trip. It depends on the trip distance, the flexibility, the location. And then from this graph, you can see that this is specific to each mode of transport. And we could think about the same for urban air mobility. How can we adapt and how can we understand the position and the role of urban air mobility in transportation overall? Normally, what we think about are the different trip segments. We see that there is walking always in every trip, but then any trip will have different trip segments. And then those trip segments will start to be from one place to the next in one or another transport mode. And this is what we've started to work on, or actually have worked on for a very long time in transportation, to find the best way to promote multimodality or the integration of different transport modes, where we could think about urban air mobility. What is its role? Where should we think about it? How can we integrate it into other places? What we've done until now is to see how that integration could start to be integrating the disruptions. How can we start to understand the coverage areas of cycling, walking, scooters, even autonomous vehicles, ride sourcing, and autonomous shuttles, because these are the ones that we've known for a long time, or for more than 5 years, let's say, that have been part of the new panorama that we see in urban transport. So we've started to look at what are the coverages that can integrate these transport services. And what we always say is we must understand that there is a core corridor and that cities will always have a main corridor where we would like to have always mass transit, 40, 50,000 passengers per hour per direction. And then along that corridor, we could have different things feeding into them. And it's really interesting to start seeing how can we integrate, how can we see the best role of each of these transport system, and how can we connect them properly. So based on that, we've started to work on some different scenarios and some different proposals. Like, for example, how can we connect every mode of transport into something that could be what we call a mobility hub? And that mobility hub could be basically a filter where you arrive in your mode of transport. And when you arrive there, you say, well, I've arrived by car, I arrived by bicycle, I arrived walking, and now I want to take another transport mode. So we could think that urban air mobility could have a role here where you could either arrive at the hub or leave from the hub in that way, provided that the corridor or the place through which you go in the urban air mobility could connect properly and through a safe location in a place where there's no risk to others, where there's no privacy implications or privacy concern from the users. And that's what we need to arrive at. How can we arrive at transportation systems that are the best solution for specific cases, where even if it's walking or cycling or autonomous vehicles or flying vehicles or bicycle, whatever, how do they connect to each other and how can they provide the best service for the trips that need to be done in certain places? But in any case, we do know that we have a huge problem in transportation. Many of you may remember this game. It was called Frogger, and it was basically a little frog trying to cross a street, and it had many different obstacles. we don't want to arrive at that. We don't want to arrive at streets or cities where we have 1,000 different vehicles entering into the ride or entering into the route of a person walking or a vulnerable user. So we need to start understanding that. And we need to start understanding that our current transportation systems don't have appropriate infrastructure, appropriate locations, or appropriate anything to the new disruption. So for example, this is a very clear example of a scooter or a couple of scooters that have arrived at a parking space. And well, they look funny because of course this is the parking space designed for a car. So the question is, how can we create a parking space that does start to work for these new tech-enabled disruptions? And again, this can be a scooter, it can be an AV, it can be a flying vehicle, whatever. It doesn't matter. What we have to acknowledge is that the infrastructure and the services that we have today are not well adjusted to what is going to come or what is coming already. And we can extrapolate this to different services as well. This is one example of something that has actually been done relatively right. There is a very specific small car in the Netherlands which is allowed in certain cases on a bikeway, but it is because it is small, low speed, light, and electric. So there you can say, okay, you are allowed in the street, you are allowed in many different streets, you're even allowed in a bikeway. So how can we start to understand that for different services, and how can we start to understand that not just for the small vehicles, but for other vehicles? And what is the framework that we have to use to start understanding this? And then just to sort of start to say a little bit of in a joking fashion, like they're very weird vehicles already since the 60s. This is the vehicle that takes you from one terminal to another in Dulles in Washington. This is, of course, the DeLorean. And when we look at it, we say, well, I hadn't seen that vehicle anywhere. And also there's weird vehicles on Mars. And there's some futuristic vehicles that we've seen in movies where we say, well, this is an obesity vehicle. Do we want that or don't we? Do we really want people sort of in those situations? Or how can we cater for the needs of everybody without arriving at sort of a dystopic future? And that's sort of the important thing that we have to start thinking about. So because we have a very complex set of vehicles, and we no longer have only car, person walking, person on a bicycle, and a bus. We have a myriad of services. We should take this as the opportunity that people saw in chemistry when they were coming from alchemy. So they were in alchemy and they said, well, we have these 4 basic elements. But now we started to find all these things from all these elements and we don't know how to organize it. And they came up with this beautiful thing that is the periodic table. But we haven't done something like that for transportation. So in NUMO, what we started to think about is what happens if we start to come up with an idea of a periodic table? What happens if we start to see the periodic table, and how can we start to say, well, let's think about specific characteristics of vehicles that we can start to categorize in one way or another. And this is sort of a very schematic way of thinking about this, but it's basically saying, well, let's think about weight as something in the vertical axis. Let's think about speed as something in the horizontal axis. And let's think about the CO2 emissions as a color range. And let's organize those in the fashion of a periodic table. And then you can see there that you can see AV shuttles, you can see the Citroën Ami, you can see an e-bus, you can see the Cybertruck of Tesla. And then you can start saying, well, let's start to look at this differently, and let's start to really categorize vehicles in such a way that we can understand this properly. And based on that, then what we came up with was a framework where what we say is, well, let's think about 5 different attributes of a vehicle or a service. Let's start by that. And let's start by defining the new periodic table based on those attributes. And when you start looking at that, you say, well, I can actually think about flying things as well. The main thing that we're trying to do here is we're trying to say, these are the core characteristics that we have in transportation. After we looked at 42 different variables and attributes, we sat down with a lot of experts and we said, well, these are the core ones that we want to understand. And then based on that, I'm going to show you exactly how we came up with this. So we came up with a platform that is not yet public, but I'm going to show you more or less how it works. You say, well, let's look at some of the typical vehicles, but then let's start looking at others. So for example, if I click on a bicycle and I want to see the bicycle, then I can go here and then it will tell me this vehicle is not likely to be harmful. But then let's think about something which may be harmful, which is an SUV. And then it starts telling me, yes, it may be very harmful because the characteristics that I showed you are not so positive. But then let's say that I go crazy and I start to experiment and I start to say, what if I have a pogo stick? And then it said, well, it's not really likely to be harmful, but you have to take care about the health issue of this because we don't really know how healthy it is to ride this vehicle. And we started to test with more and more and more sort of futuristic things. And then we said, well, what about the low-speed autonomous shuttle that appears in the Black Panther movie? And we looked at that, we looked at the characteristics, and then we said, well, it may be harmful, maybe because it's too heavy. And heavy vehicles, vehicles that are too fast, may pose a risk. And we start to start thinking about what can I do here? And then we said, well, let's start thinking about magical things like the magic carpet. It may be harmful. Let's start thinking, for example, about, as I showed you, the DeLorean machine. It may be very harmful because it's extremely fast, it's extremely heavy, and it has sort of an erratic behavior. And if you look at the dragon of one of the dragons of the movie of How to Train Your Dragon, then you can also say, well, this may be harmful to ride it. We can also see the Jetsons flying car, and then it is not so fast, it is not so heavy. So we start saying, okay, this may not be a harmful vehicle. And then based on that, then we said, well, let's start to see what are the complete recommendations of a vehicle like that. If I am using the Jetsons flying car as a commercial vehicle, then in my framework, it says you need to have a risk assessment. You need to get a driver's license as a person. Because it's a commercial one, then you need to use an operator's license. You need to provide data. You may be imposed some fees and fines, but you can request a subsidy. And then I say, well, where can I ride? Well, you can ride in the flex zone. You can't ride on the sidewalk, and you must ride on the travel lane, which is far from the sidewalk. And then if I try another one, and if I say, what if it's a personal use? Then it says it's basically the same thing, but you don't need an operator's license. And if I start playing with this a little bit more, and I start saying, well, let's look at the bicycle, then the bicycle says, well, you don't really need anything. You only need to provide some data requirements. You may be charged some fees for parking, for example, but you can request a subsidy. And you can travel in the flex zone and in the travel lane that is close to the sidewalk. And of course, you would say, well, then, of course, the pedestrian doesn't need to do anything. The pedestrian is free to roam without any requirements. Of course, a child, an 8-year-old doesn't need to go anywhere, but they can only go in the pedestrian realm, of course, the sidewalk and anything that is assigned to people on the sidewalk. And they, of course, will be able to go on the flex zone, which is a place where you take a vehicle, where you would ride a vehicle. What we haven't done until now is to see how does this work in the specific case of flying vehicles in terms of where can they ride. What we have been able to understand is to say, well, if I have an understanding of the periodic table of how can I redefine a street, which would be the way that I would say, well, if I am flying, where can I be allowed on the street? If I am flying, am I allowed to go specifically on top, but on top of what? Like, where am I allowed if I am going in one of these lanes? So what we have been able to do is, for example, say, if you're in a magic broom, then of course you have all these requirements, but you must go along the travel lane in the farther side of the travel lane. And that could be one way of understanding this. And we still need to work on this much more. We still need to keep on defining these characteristics. And I'm happy to get views from anybody to sort of see how can we define this new way of determining this urban air mobility from the point of view of urban transport, and how can we start that dialogue so that everybody can understand and everybody can see what is the best way to move forward. And with that, I hope that I encourage some thought. And of course, I have many more things to say about this, and I'm happy to see what people are happy to contribute, to criticize, and to complement the work that we've been doing. So thank you very much. I'm Carlos Pardo. I'm the Senior Advisor to the New Urban Mobility Alliance, NUMO.